Welcome back. We're going to finish up 7.4 today and have some problems. So let's begin kind of where we left off the last time. I believe we talked about parallelograms, we talked about it adding, subtracting, we talked about a scalar, multiplying. Let's work on some problems. We also found the trick in your calculator, how to find the magnitude and direction, the angle, and if you're given the magnitude and direction, can you find the components A and B? We learned all of that in the last video, so we'll have some problems covering all of that tonight. But let's start with a problem. I'm going to look, if you want to be with me, on page 337. Looking at example 4 at the beginning. I'll move that cursor out of the way. Two forces of 15 and 22 newtons act on a point in a plane. Sound like physics a little bit. Newton is a unit of forces equivalent to 0.225 pounds. If the angle between the forces is 100 degrees, find the magnitude of the resultant force. Okay, so I've got two magnitudes, two vectors. Okay, one has a force of 15 and the other 22, meaning they're a little bit more than, let's do that. Okay, so we have 100 degrees between the two forces. One has a magnitude of 15 newtons. Okay, the other has a magnitude of 22 newtons. Okay, and it's asking what is the magnitude of the resultant force. Meaning, if something is pulling right here along this with a force of 15 newtons, and someone is pulling from that same point with a force of 22 newtons, how much force are they creating together? Okay, what is the resultant vector's magnitude? Okay, so in here we're going to do the parallelogram, meaning I want to know resultant vector. Here's my resultant vector. So it's moving forward at how much? Now, what we have to do is remember our rules for a parallelogram, okay? I need to know, does this cut this angle in half? No, it doesn't. But if I draw a vector that is 22 newtons on this side and a vector of 15 units on this side, okay, so I'll erase the last little bit of my green, kind of make them connect. What is the resultant vector? Meaning, what is the diagonal? What's the length of the diagonal? Okay, so we know this whole angle up here has to be 100, not necessarily drawing the scale. So what are our other two angles going to be? That's right, they have to be 80 degrees. How are we going to find the length or the magnitude of our resultant vector? I'm just going to put an X there. We have two sides and an included angle. Can we use the law of cosine? That's right. X squared equals 15 squared plus 22 squared minus 2 times 15 times 22 times cosine of the included angle, which is 80 degrees. Okay? Let's keep going. 15 squared plus 22 squared minus 2 times 15 times 22. Pulling up my calculator here, and we will have that answer. They put it all there for us, but I like to just plug it in. Let's clear all that. It's probably from when we did this the other day. 15 squared plus 22 squared minus 2 times 15 times 22 times cosine of 80. That should be correct. We get this number 594 point, etc., etc. We're taking the square root. Second answer, we get 24.38. Okay, sig figs. Are they important? Generally they are. Approximately 24 what? Newtons. Okay, the resultant force. somebody's pulling this direction at 15 newtons, somebody's pulling this direction at 22. They're creating a resultant force of 24 newtons that are going forward in that direction. Okay? So we need to do another one. Let's go ahead and do another one. Two forces of 32 and 48 newtons act on a point in the plane. If the angle between the forces is 76 degrees, find the magnitude of the resultant vector. Okay, so I'm going to draw my vectors. I've got a 32, and then I've got one that's longer, it's 48. Angle between them is 74, so it's not 74, it was 76 degrees. And 48 newtons. What is the magnitude of the resultant vector? Okay, if you want, just think, oh, I can just think of, well, I know I have to find some other things. Okay, so is that one parallel to the 48? Because what it's doing is creating a parallelogram. And is this one parallel to that? That one's better done. So these sides are parallel because it's a parallelogram. This angle is 76 degrees. What's the other angle? I'm pretty sure it's 104 degrees, correct? What are the other two sides? And it says, what is the angle between, what's the magnitude of the resultant vector? What is going on in that 76 degrees? You're never going to use the 76 degrees in your calculations. You're always going to use the supplementary angle when you're finding it, okay? So when we want to find the resultant vector, we're going to use the law of cosine every time. So I would say r squared equals 32 squared plus 48 squared minus 2 times 32 times 48 times cosine of the angle that wasn't given to us, but is supplementary to it. Okay, there you go. Setting it up is the hardest part. Plugging it in your calculator should not be the hardest part. All right, so here we go. 32 squared plus 48 squared minus 2 times 32 times 48 times cosine of 104. Now, look, try to always look glance back at my calculators to see that I put in anything crazy. Okay, second square root, second answer, 63.8 newtons. Are we leaving it as 63.8? No, we're going to round it up. The resultant vector is 64 newtons. Okay, a little bit of application. We're going to talk about that a little bit more. Okay, so that's how we're going to use parallelograms. We have done all the operations. The only one we haven't talked about that we need to talk about is multiplying. How do we multiply vectors? Because it's going to help us with something else. Okay? When we are multiplying vectors, if you have a vector u dot or times vector v, okay? Vector u times vector v, we call it the dot product. Okay, the dot product. If vector u is given by components a and b, and vector v is given by components c and d, okay, the dot product will simply be the a times c, so your x values. The dot product will be, so here we go, u dot v will equal, and it will just be one number also. Sorry, it will just be one number. A times C plus B times D. Okay? A times C, your X's multiplied together, added to your Y's that are multiplied together. Okay, so if we have an example, if you really is 2 comma negative 3, and v is really 3 comma 5. We're going to go u dot v will simply be 2 times 3 plus negative 3 times 5. Okay, so we have 6 plus negative 15. So what's 6 plus a negative 15? We should get, I believe, negative 9. Okay, that is your dot product. It's going to be one number when we're multiplying vectors together. Okay? Using the dot product, we can do a few other things also. What if we have a scalar number or even another vector? If you have a vector w plus u plus let's put a u there. Vector w plus vector u times vector v. That's what I meant to do. Okay, it's just going to be exactly like the distributive property. This will really be vector u times or dot w plus vector v dot vector u. Okay, so you would have to do the dot product twice. If you have something that's squared, you would just multiply it times itself. Okay, they have a whole little box. Distributive property, it's all commutative property. What if we have a constant k times u, ku times vector v, or dot vector v? Well, you can simply do as a constant and then u dot v. Your book doesn't do the vector symbols a lot. Okay, it's very big in geometry that they do them, but this one doesn't. They just bold them. Whatever, I can't show you bold things. Okay, so 2 pieces of the dot product that we would use. Now, why do we need the dot product? On page 340, they go into a long explanation. I say long, it's not that long. But it talks about the dot product of 2 vectors can be positive, 0, or negative. We'll talk about what it is if it's one of those. A geometric interpretation of the dot product explains when each of these cases occurs. This interpretation involves the angle between the 2 vectors. Okay, so now we've got 2 vectors, and we can talk about the angle between them, if you're not given the angle like we were in that first problem we did today. Okay, so consider the vectors u is AB and V is CD, like we did earlier. The angle theta between u and V is defined to be the angle having the 2 vectors as its sides for which it's between 0 and 180 degrees. Okay. The following theorem relates the dot product to the angle between the vectors. And they'll tell us that they talk about it later. If we have 2 vectors and we don't know the angle between them, okay, if this is u, let's change color. I'm in blue a lot today. This is vector u and this is vector v. And we want to know what is the angle between these 2 vectors if we don't already know it and if they don't give it to us. Okay, let's do some numbers. We'll use the ones they give us. 3, 4, and 2. Well, this is obviously not 2, 1. So we're just going to make it up. We're going to do 5, negative 3. Okay? Can we find the angle between? This says to find the angle between 2 vectors. So we're going to find the theta. We will do this. Cosine theta will equal u dot v over the magnitude of u times the magnitude of v. Okay? So if you're given components of two vectors, can you find the angle between them? Yes, you can. You can solve for that theta. Okay, so how are we going to do that? First, we're going to find the dot product. That's going to be our numerator. What is the dot product of this u dot v? U dot v. It's a times a, or x times x, so 3 times 5 plus 4 times negative 3. So I believe that is 15 plus a negative 12, which I believe is 3. So my numerator is 3. Now I need the magnitude of u times the magnitude of v. Oh, I have to do something else to find the magnitude. How do we find the magnitude? There was a quick formula. The magnitude of u, I'm going to go over here, equals the square root of 3 squared plus 4 squared. It's like the Pythagorean theorem if we had drawn a triangle out, correct? And this is 3 and that's 4. Again, it's not drawn to scale. So 3 squared plus 4 squared, oh, I believe that's 25. The square root of 25 is 5. So here I have 5 times, what's the magnitude of vector v? The square root of 5 squared plus negative 3 squared. We have 25 plus 9. Oh, I did not make this come out very pretty. That's what happens when I make things up and don't go with what they have in the book. Well, theirs didn't come out pretty either. They just left it in square roots. The square root of 34. 5 times the square root of 34. Okay? So then we're going to plug all this in our calculator. We'll go back to the formula. U dot v, so I have 3 divided by, so I have cosine theta equals cosine theta equals 3 divided by 5 square root of 30. Here we go, I'm scrolling this way. Okay, so I have 3 divided by 5 times the square root of 34. Oh, I don't need that. I don't need that parentheses. There, parentheses on the outside of it. Okay, and we have this approximately approximately 0.10289. Leaving all that in my calculator. Is that my angle? No, it's cosine theta. So I'm going to hit second cosine. So I need the inverse, right? The inverse is 84 degrees. Okay? So cosine theta is this, our theta. Now, let me find a different color. Our theta for this problem is 84 degrees, approximately. 84 degrees between these two angles. Not quite a right angle, but almost. It could be. Let's do another one of those. If I give you two vectors, vector u is simply 5, negative 12. And vector v is 4, 3. They're being nice. Pulling problems from the book. Can you find the angle between u and v? What are we going to do first? Well, it depends what you want to do first. I'm going to write the formula first. Cosine theta equals u dot v over the magnitude of u times the magnitude of v. Okay, that's my formula. And then whatever you have to do to find u dot v, here we go. I'm going to go down here. U dot v is simply 5 times 4 plus negative 12 times 3. So I have 20 plus negative 36. I believe that is negative 16. So on the top of my equation for my formula, I've got a negative 16. Okay. Next, I'm going to find my magnitude. The magnitude of u. The square root of 5 squared plus negative 12 squared. 25 plus 144, I believe is 169, which is 13. Wow. So I've got 13 times, I don't know what I'm doing there, times, let's find the next one. Let me find a different color to write in. Let's go, it's really purple. Now the magnitude of v, the square root of 4 squared plus 3 squared. Well, I hope we all know this is the square root of 25, which is 5. So, negative 16 divided by 13 times 5. I'm pulling up my calculator again. Here we go. Negative 16 divided by parentheses 13 times 5. And you do need parentheses. You can't do that without, because it will divide 16 by 13 and then multiply that answer by 5. Parentheses are important. Negative 0.246. That's my cosine theta. Second cosine, second answer. And I have 100. My theta is approximately 104 degrees. The angle between them. Okay? They give you a little tip at the bottom in yellow. If your dot product is positive, it will be an acute angle. We just did that one in the last one. If your dot product is negative, it will be an obtuse angle. And last, if your dot product is 0, okay, your angle will be a right angle, okay? If your dot product is 0, means cosine theta equals 0. When does cosine theta equal 0? At 90 degrees. That's right. Okay. They talk about that. There's a lot in this section. I'm going to assign some problems, and then we won't have another video tomorrow. Just work on your problems, and they'll be due tomorrow. And then we'll start next week with 7.5, wrap this up, and then we'll be done. Awesome. Okay, so I'm going to minus this. Go to the next page, your 7.4 problems. Will be, there's quite a few, that's why you get 2 days to work on them. We're going to do 5 through 21, just the odd numbers. We're going to do 33 and 30, ooh, that was supposed to be a 33 together. 33, 35, and then we're going to do 43 through 53. Just the odds. Then we're going to do 59, 63, let's see, 71, 74, 77, and 80. There are a lot, so ask me questions if you need some help. Look back at the lesson, look back at your notes, and I'll talk to you later. Bye.